Good day, class. Welcome to our channel, Winners Academy 5074. Today we are treating chemistry, and we have two topics in mind: atomic mass number, atomic number / mass number, and also looking at empirical formula. After empirical formula, we're looking at molecular formula. But this is where our focus for today is going to lie. Now, anytime you see an element, because in the previous class we treated elements, we talked about the first 20 elements, and we listed their atomic numbers. So if you have an element X, here should be A, and this should be what? B. You see two numbers here, subscript and superscript. These two numbers here, this is standing for the what? Mass number. And this is representing the what? The atomic number of the what? Of the elements. You can see that, right? Now, what is the difference between the atomic number and mass number? The atomic number is the number of protons contained in that element. The number of protons. So we can say atomic number equal to number of protons. Number of what? Protons. Now, if this is the number of protons, every element has the nucleus and electrons around it. I say what? Every element has the nucleus and what? Electrons around them. Now, the nucleus is made up of what? The mass number. The nucleus is made up of what? The mass number. And this mass number contains what? The number of protons and the number of what? Neutrons. Number of what? Neutrons. All these make up the what? All these make up the nucleus. Are we there? The nucleus of the element. But we have electrons around. And these electrons are equal in number to the number of protons. That's why we usually replace this with this, protons and electrons. Are we together? Now, if you are with me, we would say that mass number equals to number of protons plus number of what? Neutrons. Is that clear? I hope we're on the same page. Now we continue. I have something like an element. Let me say I have sodium, Na 2311, and I'm asked to find or give us what? Give us the mass number, the what? The atomic number, the number of protons, number of neutrons, and what? The number of electrons. Let me not just take our time with that. So she give us this from this guy here, this guy, sodium. Are we together? Now for this, you say that the mass number is this number here. So about 23 is the mass number. What is the atomic number? Easy to identify. 11 is the what? Atomic number. Now, what is the number of protons? Since we know that this is made up of what? The number of what? Protons and number of neutrons. And number of protons equals to number of electrons. I said that. The number of protons equals to number of what? Electrons. Therefore, we have that, since this is that the case, we have the number of protons here will be equal to what? The atomic number, the same thing. So number of protons is equal to what? 11. Then what is the number of neutrons? Number of neutrons now will be what? 23 minus 11, which will give you what? 23 minus 11 will give you what? 12. And the number of electrons is what? 11. So I've explained this, and I hope you are following. Now, sometimes you will see things like, let's say chlorine. Chlorine, you see 35.5, and you see 17. Are we together? Now, in this case, you'll be wondering what is the problem. It is because this guy, chlorine, has isotopes. And what is isotopy? Isotopy simply means that these elements exist in a form where the atomic numbers are the same, but their mass numbers varies. Therefore, in their level or ratio of relative abundance, if you run the calculation, you'll be able to get this value, 35.5. In nature, we can have 37 and 17 to be for chlorine. This is an instance I'm giving you. 37 and what? 17 to be for chlorine. Therefore, if it's in this case, I can easily solve this. But in this case now, I can't just say I want to be solving it. No. They need to tell me the isotope. What kind of isotope? Is it this one that I'm using? Or is it one for 35, 17 I'm using? Do you understand? This one now is what? In this case, we're looking at what? We're looking at relative atomic mass of this guy. We're going to solve it using different calculation. The relative abundance in nature. Use that calculation to solve it. Don't worry, we're going to do that in our next classes or videos. You're going to see calculations on that. So I believe you have understood this concept very well. The next thing we have to do is to move and delve into the realm of empirical formula. So after this short break, we shall continue with empirical formula. Welcome back to our channel. So we are looking at the empirical formula. Empirical formula of a compound is the simplest formula of that compound. The simplest formula. For example, we have that glucose has C6H12O6 as its what? This formula. Okay. So since glucose has this as a formula, we divide this to the what? The simplest ratio. Divide all 2 by 6. You have C1H2O1, which can be written as what? CH2O. So this is what empirical formula of a compound, and this will say to be what? The molecular formula of the compound. Are we together? Now, in that note, if we're on the same page, let us look at these questions, these 2 questions. The first one is a certain hydrocarbon contains 14.3% of hydrogen. Determine its empirical formula. When we talk about hydrocarbon, we are dealing with a compound that contains only 2 elements, hydrogen and carbon. So in this case, we are looking at hydrogen and carbon to be the what? The only elements contained there, hydrocarbon. Therefore, if we look at this question, hydrogen has what? 14.3%. And we know from our basic mathematics that percent means in each 100. Therefore, 14.3, remove that from 100, we're having 100 minus 14.3. I have 7, and I have what? This is remaining 9. This is 99, and I have 5 and what? 5, 8. So I have 85.7. So this is what? 85.7% for this guy here, right? So the next thing we do is to divide 2 by the what? By the what? Can somebody tell me? The simplest form of this is what? For you to divide 2 by your mass number. Your mass number. Divide 2 by your mass number. In this case, the mass number of carbon is what? Mass number of carbon is 12, and this is what? 1. So 18.7 divided by what? Divided by 12 will give me 7.14. 7.14, and this is what? 14.3. Right? Now the next stage, this first stage, you say what? This first stage is what? Divide 2 by mass number. That's the first stage. We are dividing 2 by the what? Mass number. Now the next to divide by the what? The least value. We have gotten this now. So we say what? Divide by the what? Least value. So we say divide 2 by least value, the smallest value here. What is the smallest value here? I believe you got that right. 7.14 divided by 7.14, and this is 14.3 divided by what? 7.14. So this gives me what? 1 and 2. Therefore, the empirical formula is what? CH2 for this. The empirical formula is what? CH2. Now look at this other question. A certain toxin from mushroom contains 7% hydrogen and 14% oxygen. Determine its empirical formula. Now let us solve this question. Now we're looking at mushroom. Mushroom, we could say this is an organic compound. An organic compound will contain carbon, hydrogen, and what? Oxygen. Therefore, we'll not just look at this hydrogen and oxygen here. We're going to be looking at the hydrogen, the what? Oxygen, and carbon. Those are the chief constituents of an organic compound. Some organic compounds can contain others. We are not looking at organic chemistry today, but just understand that concept, that when we are solving questions in empirical formula that has hydrocarbon, you use carbon and hydrogen. But when it's just in this case where you are not told hydrocarbon, and you see that this percentage here and this percentage here does not sum up to 100, the remaining one will be for the third element, and the 3 elements there must be what? Carbon, hydrogen, and oxygen. I hope you are following. Now listen, we look at this. You say what? This is what? Hydrogen is what? 7%. Oxygen is what? 44%. The sum of these two gives me 51%. And 51 removed from 100 gives me what? Gives me 49%. Are we together? Now the next thing I'll do is my first step. The first step is to divide 2 by the mass number. So I say what? Dividing through by the mass number. What's the mass number of carbon? Atomic number what? 6. Mass number 12. So how about 49 over 12? Then this is 7 over 1. And this is 44 over 16. Is somebody with me? Now, I look at this and I have 49 over 12 to give me what? 49 over 12 gives me what? 2 points what? 2 points. Let's use our calculator here. I have 49 divided by 12 gives me, okay, 4.08. Then this is 7. And I have the next one, 44 divided by 16. Gives me 2.75. Now the second stage is what? Divide 2 by the least value. When I'm dividing 2 by the least value, what's the least value here? I have 4.08 over 2.75. Are we together? I have 7 over 2.75. This is 7. This is 7 over 2.75. And this is what? 2.75 over 2.75. And what are my answers now? I have 4.08 divided by 2.75 gives me 1.48. 1.48. The next I say what? 7 divided by 2.75. Okay. 7 divided by 2.75 gives me 2.55. Right? The next I say 2.75 divided by 2.75 gives me 1. Now I look at these things here. I cannot just approximate from this because the value is too large to approximate it to say 1 or 2. And this one too is too large. Look at this place. From 0.55, you now approximate it to 3. In this case, you don't just approximate like that. What you do first of all is to multiply with numbers. You check for prime numbers. Prime numbers 2, 3, 5. You check, you multiply them until it gives you in the order where they can easily be approximated. Like here, when you divide this, you have 1. But here you'll be having 2 points, maybe 2.0 something, and you can easily approximate 2.1. When you're having something like this, you start testing by what? Multiply by 2, multiply by 3, multiply by 5. So this one now we say what? 1. Let's start with 2. 1.48 times 2. 2.55 times 2. And what? 1 times what? 2. This gives you what? Gives you 2.96. Are we there? This gives me 5.10. 5.10, and this guy gives me 2. You can see now that I can approximate it to be what? 3. You see, very close to 3. This is very close to 5, and this is very close to what? 2. So now the empirical formula is what? The empirical formula is C3H5O2. Is that clear? With this, we have been able to do justice to empirical formula. So in our next class, by the grace of God, we're going to be looking at molecular formula and isotopes, relative atomic masses. Thank you very much for watching. May God bless you as you like, share, comment, and subscribe to our channel. Thank you very much.